Okay, now we have magically flipped it over, and as you see, I removed the rectifier tube to do that, and on one side it's resting on the power transformer, and the other side I put the box of the new output transformer underneath, so it's nice and level. So as you can see on the inside, it had these blue coupling capacitors. Those two will need changing as well, but the big ones were here, and those got changed for these very cheap and easy peasy orange drops. I don't recommend to use them because they have a very basic sound quality, but at this point what the owner of the amp wanted to do is just to make sure that this thing works at all, because if it has major problems and he starts dropping on like Jupiter beeswax capacitors or something expensive, and then later find out that this blasted thing doesn't work, then it's just a major waste of time and effort and money, right? So this is a great recommendation for you, that when you are trying to revive an older amp, then just first put in basic parts. So these are very basic coupling capacitors. Also on the other side, I'm not sure, can you see those? Yep, there we can see those were the power supply capacitors. Those are very cheap electrolytics, and if the thing works out well, then he is going to go ahead and change them to much higher grade capacitors. So here's the deal, that he is pretty handy with a solder station, with a soldering iron, and he changed all of these himself. And after that he said like, okay, Janos, can I turn it up on, just plug it in the wall? I said no, because if there's some problem with the unit, you plug into the line voltage and the whole thing will just blow up, and something will melt or just get even more damaged than it was. So how you always must power up an old unit even after basic repairs is that you need a variac. So you need to plug it into a variac where you can adjust the line voltage with this, and basically as you ramp up the voltage, then the current consumption will go up with the voltage, and if it goes up too high, then you know that there is a short, and you can catch it while the unit is already only at 10 volts or 20 volts input instead of 120 volts input. So there's like just you can turn it off before anything bad happens. And as it happened, we turned it on, and it powered up nicely. Power consumption was about like 0.6 amps or something like that. I forgot, it was under 1 amp, and it was nice. It was quiet. I hooked it up to my test speaker. I normally don't have anything that connects to these jacks that musicians use for their instruments, like, you know, that sort of connection, this sort of jack, for because I do 2-channel stereo audiophile stuff, and we just don't use speaker connectors, loudspeaker connectors like this. But you see this happening in the pro industry. If you have a professional gear, they use these guys for both to plug in your guitars and also to plug in your loudspeaker. Very convenient and very easy. However, for me that was not an option. So what I did, because my test speakers have just bare wire ends, so I can hook them up to a power amp, but in this case what I needed to do is that I just soldered the speaker wire directly to the output jack's terminals, and that's how we tested it out. And that now I removed them from there. Now it's different, and I'm showing the inputs there. So I hook them up here. These are the outputs. Yeah, these are the guys where it says speaker. You see, I just need to read. That's it. So this is a 20 watt output amplifier, push-pull 6v6 Fender Reverb Deluxe. So basically I soldered the leads in directly and we tested it out, and as it happened, it was nice and quiet, but the peak output was absolutely minimal. It played like super quietly. We could hear from the loudspeaker, from the test speaker, like a nice and quiet playing, but it just would not go higher than that. And so how to troubleshoot next? So now we have established that actually the unit makes sound, it's stable, it's not consuming more amperage than it should, and so what can we do next? As you see, that place should be where my oscilloscope is, but right now it's under repairs. I still have not undertaken the rebuild of the oscilloscope, which will be a quite significant undertaking. However, it has been postponed because I've been rebuilding the engine of my car, and that takes precedent over having fun with the scope. So without a scope, what can we do? What you can do? So what you can do is get your meter, get your multimeter, and oh, where is the other one? Just one lead there. I need to find the other one. Okay, so get your multimeter, and then what I did is just I tested first the input, and my friend, he was playing the bass guitar. Nelly has a double bass, a really nice 5-string graphite neck Horner, and he was playing it. So I measured that at peak it was feeding 150 millivolts to the first 7025 tube, and I measured that after the first coupling capacitor, after the plate of the first stage. So how did I establish that, where it is? Because I don't know, I never seen the schematics of this amplifier. All I see is what you see in front of me. So what I did is go, you see there's the input, and where is the input going? So this is, you see, that's the input, and the input goes, just trace that, it goes there. So this is the input tube, and the signal goes to that grid. So that's the grid of the input tube, and because this is the 12VX7 family, then you know that this is the cathode, grid and plate, and there we go, bang. So this will be our first coupling capacitor after the plate. So if I measure with a multimeter here this lag, which is the decoupling the DC on the plate between here and the chassis, now I can measure what is the output of the first tube section. And I measured a peak of 15 volts AC, which is 100 times greater than what I measured here. And that is all good because the gain of this tube is 100. So I should measure voltages 100 times greater here compared to here on the input. So basically I have established that the first stage works. Now after that it gets way more complicated because we have one bunch of tone controls added, volume, tone, all sorts, and based on their setting and how the feedback loops and everything is happening. Now we cannot tell more about the gain configuration of this amplifier. So what I did is that I jumped to the very end and looked at the 6v6s and see whether I have a signal from them. So here I can look at the grid of the 6v6 tubes to see if they are receiving signal, and look whether they are doing their work or not. And I was measuring about 26 volts on them. So basically the power tubes are receiving signal, full power signal, so the amplifier should be able to deliver about 20 watts into those loudspeakers. However, so it means that all the circuitry here has an integrity. So basically, signal is coming from the input through to the output tubes. And now the big question is, why are we not getting any sound? Why I was getting maybe like about 0.2 watts or something like that on the output instead of the 20 watts peak. And if everything up to here checks out, then the problem must be with the output transformer, which is this gray guy here. And how can we proceed to check whether there's a problem with it or not? So number one thing, turn off the variac. Make sure that there's no voltages present on the amplifier. You can use a bleeder resistor to drain the high voltage. And when everything is bled out, then I measured whether the primaries of the output transformer are intact. And you see the primaries are connected by the blue wire and by the brown wire. And here the red wire, that's the center tap of the primary coil. So I measured the resistance between these 2 points and those 2 points, and both of them were measured okay, 220 ohms each. But to do that, first you need to really drain your high voltage, because if there's significant voltage present and you want to measure the resistance with maybe like a couple hundred volts stuck in there, then you will just fry your meter. So anyway, primaries were fine. However, when I measured the secondary coil, the output, I was expecting about 1 ohm resistance, and I measured only 0.1 ohm resistance. So it means that the secondary of the output transformer is cooked, is shorted, partially shorted. It's not a full short, because then I would have measured 0 ohms. But so what we did after that is look online, Google up the amplifier, the Reverb Deluxe, and look for transformer alternatives for the output transformer. I found a replacement original over $200, and then my friend said no thank you. And then I found this much cheaper. This was under $40. It's a Hammond remake of it. It's a 1750H. That's the model number of the transformer. And look, it's on the outside, the casing, the end bars, so everything which is like this stamped iron shroud around it, end bars, and then the casing, it's all exactly the same on this aftermarket remade Hammond version and on the original. The only difference is that the Hammond has plastic covered leads and the original had cloth covered. So this has a nicer tone to it, a little bit nicer than the Hammond. And also the original has neater packed laminations. With the Hammond, they are more uneven than the original. Other than that, they look exactly identical. And so I took out the old one after it arrived yesterday evening, and that's how I spent yesterday evening, and put in the new output transformer. And to my surprise, actually, it turned out that when I put it in, I still measured 0.1 ohms for the speaker terminals. And I said, what's going on? Very easy. So what was going on is that the speaker wire terminals, these guys, the connectors are shorted. So the main problem with this amp was that the connector itself, internally, these guys here, they have an internal short that's an almost dead short to 0.1 ohm. and when I measure the secondaries, it's like it measures 0.7 ohm, and the remake measures 1.1 ohm for the secondary, and they measure 220 for the primaries, both of them. So as you see, the original is most likely has a partial short in the secondary anyway. So being used with these shorted leads, what does it mean? It means that when you plug in a loudspeaker to this unit, then the power, instead of being delivered to the loudspeaker, it's going to get shorted and it's going to cook the secondary winding of the output transformer. And after a while, it's going to damage it. And that's what happened to this fellow. And now we have the replacement inside. And what I did is that at one point I will need to change these poor buggers to functioning ones. Now I just have the secondary leads of the output transformer, and I have soldered them directly to the speaker wire. And of course there's a white wire too going there, and that's grounding, that grounds the secondary. And I put temporarily these tapes around it so that if I flip it over, they don't short something out accidentally. This is just temporary measure for testing the unit. This is not how it's going to look like when it goes home. So basically this was the story of figuring out what's wrong with this unit without being too technical about it, without having to look up the schematics, learn really involved things, just do common sense things. And of course you might ask, I have no idea what common sense is, but hopefully now I give good starting points where you can think about where you can start, what can go wrong with an amp. And of course it doesn't stop here. There's so many things to be done with this unit, but at this point it is already operational and functional. And yesterday I had tremendous fun. I think for about an hour I was just playing with the bass guitar with it, and as you might know, I don't play guitar, so I was just making sounds with it. It was tremendously enjoyable. So thank you guys for tuning in. I hope this was educational, and all of you can use the information to help revive a tube amp for yourself. Thank you. Please like, subscribe. Bye bye.